Okay, so here we are, and you don't understand what I've been through to get this video to you. All right, so first of all, there is a mistake on this page. This should be 2x plus 1 because that's what the graph is. It's the line that it's graphed. It's 2x plus 1, so we're going to change this to an addition sign. We're going to change this to an addition sign. So it should be 2x plus 1. All right, so here we go. Okay, some things to remember. A linear inequality has more than one solution. It is all numbers that satisfy the linear inequality. So therefore, y is greater than 2 are all numbers that are greater than 2. All numbers. So 5, 7, 25, 2,764. Okay, all numbers that are greater than 2, 3. Okay, that's what y represents. So y, which is greater than 2x plus 1, are all ordered pairs that satisfy the statement. And since this is an inequality, there are a lot of ordered pairs that satisfy this statement. So when we look at this problem right here, we're going to see what works and what doesn't work. So does -1, 1 satisfy the statement? Okay, so we have -1, 1. So this is x and this is y. We already know this. Just want to review again. So y is greater than 2x plus 1. That's what this is, 2x plus 1. So when we put in 1, 1 is 1 greater than 2 times -1 plus 1. That's what it's asking. Well, 1 is greater than 2 times -1 is -2. -2 plus 1 is 1. So -2 plus 1 is -1. So is this a solution? -1, 1. Yes, it is. And I'm going to make it green because it's a solution. All right, -1, 1 works. Green works. You might not have green, whatever. We get over it. All right. Is 1, 1 a solution? What about 1, 1? So is 1 greater than 2 times 1 plus 1? 2 times 1 is 2. 2 plus 1 is 3. Is 1 greater than 3? No. This doesn't work. Guess what? The non-working colors. They will be red. So 1, 1 is not a solution. What about -2, 0? -2, 0. -2, 0, is that a solution? All right, so this is x and y. We already know that. So is 0 greater than -2? So that should be 2. 2 times -2 plus 1. So 2 times -2 is -4. -4 plus 1 is -3. Is 0 greater than -3? Yes, so -2, 0 works. -2, 0 works. What about 2, 0? 2 zeros right here. All right, is 0 greater than 2 times 2 plus 1? 2 times 2 is 4. 4 plus 1 is 5. Is 0 greater than 5? That's a lie. No, you don't work. Yes, you work. So we're going to say that 2, 0 does not work. So here's the thing, everybody. Y is greater than 2x plus 1. Why are these working over here? Why are these working? Y is greater than 2x plus 1. And why are the dots over here not working? Okay, and so I'm going to take you back to this definition. Where is it at? At the bottom of one of these pages. Where's it at? Linear inequality represents all. Oh, these are old notes. Okay. Well, I'm just going to read that. Linear inequality represents all points. Well, let me read it for real. Go back. A linear inequality describes a region of the coordinate plane that has a boundary line. Every point in the region is a solution of the inequality. So a linear inequality describes a region of the coordinate plane that has a boundary line. Every point in the region is a solution of the inequality. So this is what's happening. Let's do 2 more. Let's do a point on the line. Okay, let's do, if you have some room, let's try, I heard somebody say 1, 3. Try 1, 3. Okay, let's see if 1, 3 works. 1, 3. Do you work? Are you a solution? So we will be saying 3 is greater than 2 times 1 plus 1. All right? 3 is greater than 2 times 1 is 2 plus 1 is 3. Is 3 greater than 3? No. That doesn't work. You are red. Let's try one more. Let's try -1, -1. Let's try -1, -1. So we're saying -1, -1. is negative 1 greater than 2 times negative 1 plus 1. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Is negative 1 greater than negative 1? No. So we're realizing that the points over here work, but the points over here do not work. Okay? And then the points on the line do not work as well. So, a linear inequality describes a region of a coordinate plane, and it's saying cut off by a boundary line. Every point in the region is a solution to the linear inequality. Okay, so I'll take a moment to put this definition so you can see it in the video, and you really want to know this definition to refer back to it. So it says a linear inequality describes a region of the coordinate plane that has a boundary line. Every point in the region is a solution of the inequality. So we're noticing that there is a boundary line. This line is the boundary line, okay? And so what is happening is that the points above the line are working, okay? And the reason why they work is because y is greater than 2x plus 1. This 2x plus 1 is represented by this line, okay? So y is greater than 2x plus 1. So every point over here is working. If we use, say for instance, just do mental math real quick. If we use, let's use 0 because it's real easy, negative 3, 0. So negative 3, 0. So we're saying 0 is greater than negative 3 times 2 is negative 6. Negative 6 plus 1 is negative 5. 0 is greater than negative 5. It works. Let's use a point. Let's try negative 2, and this is 1, 2, 3. Negative 2, 3. I'm already knowing it before because I know that. Negative 2, 3. So 3 is greater than 2 times negative 2, which is negative 4. Negative 4 plus 1, which is negative 3. 3 is greater than negative 3. Now, the reason why this is not working on the line, because the previous video showed us that equations are equal. This is not equal to. So when you end up choosing the points that's on the line, you realize that 3 cannot be greater than 3. Negative 1 cannot be greater than negative 1. They don't work. So a linear inequality describes a region. So the region that is working is the region above the line. The region above the line. Now some people ask, well, how do you know what's above the line? Okay, and I'll show you that in a second as well. The region above the line. All right. You can think about y. Y is greater. So this is going up, going greater. So this is above the line. Y is above the line. And this is constantly, for infinite measure, going down. So this is above the line. This is, keep it crisp here. This is below the line. So what is the region above the line? The region above the line is where the y's increase. Y is greater than 2x plus 1, above the line. So every point in this region works. Every point. And so what we're going to do, we're going to shade. I'm going to show you that in a second. And then what is on the line does not work. But how do you represent that? It can't be equal to. This is how you represent that. We represent that instead of these open circles, we represent the line being dashed. Because that shows that this is not equal to. So we make a dashed line to show this is not equal to. Your quiz is going to be you explaining this. Okay? I'm going to give you an inequality and you're going to tell me why is this region graph? Why did you shade here? Because y is greater than 2x plus 1. This region represents everything greater than 2x plus 1. Y being greater than 2x plus 1. Y is the line dashed because it's not equal to. Okay? Why doesn't the points on the line work? Because the points on the line are equal to 2x plus 1. And this is not equal to 2x plus 1. It's greater than 2x plus 1. Let's get into it. Alright, so here's some hints. Step 1, solve the inequality for y. It must be in slope-intercept form in order to use what I just showed you. I'm going to get into this tomorrow, so you're not going to have to worry about that today. Graph the boundary line. Use a solid line for greater than or equal to, less than or equal to, and greater than or equal to. Use a dashed line for less than and greater than. Shade the half plane above the line for y is greater than or equal to, greater region. Shade the half plane below the line for y is less than and y is less than or equal to, the lesser region. You can mentally check your answer, and I'll go through this part, the hint, tomorrow. Let's get into it because I know some people are like, I don't get it. All right, let's graph it. So y is greater than 2x minus 3, 2/3 x minus 1. Okay, so I know that for a linear inequality, it starts at -1, starting at -1, and what's the slope? Up 2 to the right 3. Up 2 to the right 3. Down 2 to the left 3. Down 2 to the left 3. Okay, so now ask ourselves, what kind of line should I have? Well, it's not equal to, so it's a dashed line. Dashed line. Little arrow right there. And then where should I shade? Should I shade the lesser region or the greater region or the lesser region? Well, this is y is greater than. Everything greater than is above the line. So we shade above the line. So every ordered pair in this region is a solution. Every ordered pair above this line, not on the line, is a solution. Let's look at another one. So we're going to graph the y-intercept. The y-intercept is 1, 2, 3. The slope is down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Get the point. Okay, what kind of line is it? It's solid because it's equal to. Slope is rising to the left. The line is rising to the left to show that it is a negative slope. And where are we going to shade? Well, this is less than. So where is the line? Start at your y-intercept and say, oh, above the line is here because the y's grow. Start at your y-intercept. Below the line is over here. So we're shading everything less than. Everything over here is less than that, including what's on the line because it's equal to. So that's our shade. All right, let's look at y is greater than -4x. All right, the y-intercept is 0. And then my slope is -4, which would be -4 over 1. So go down 4 to the right 1. For the sake of time, I'm not going to do as many points. Go up 4. That's 4 to the left 1. What kind of line will I have? Well, this is a dashed line because it's not equal to. Dash because it's not equal to. Where am I shading? I am going to shade in the region above. So find your y-intercept. Where's above? Above is up here. So we're going to shade in the greater region. So we are shading up here. All right. All right, let's look at this one. Y is less than or equal to -4. Well, my y-intercept is -4. And then what kind of line will I have? Well, I know this is hoi. So this is a horizontal line. Solid, yes, because it's equal to. So I have a horizontal line. Where am I shading? Where am I shading? Well, y is less than or equal to -4. So the y's that are less than, y-intercept is here. This is greater. Less than region is down here. A linear inequality describes a region. These are our regions of a coordinate plane that has a boundary line. This is our 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 boundary line. Every point in the region, every point in that region, in the shaded region of the inequality is a solution. That is what that definition is saying. Okay, so we start at 2, and we go up 1 to the right 3. Again, time is running out on me. To the right 3. Is it a solid line? Yes, it's a solid line because it's equal to. Time is running out. My lines are getting horrible. Where are we shading? Find your y-intercept. Greater than. Greater than is above the line. So we are shading above the line. And then the last one. X is less than 3. This is bucks. So we go undefined slope at the x-axis. Vertical line. Go to 3. 1, 2, 3. Is it a solid or a dashed line? It is a dashed line. It is not equal to. And then where am I shading? Well, where is x less than 3? This is the vertical. X is less than 3 on this side of the line. So we are going to shade on this side of the line. This is where our shade goes. So for your quiz tomorrow, you have to, I'm going to give you a definition. You're going to break down every part of the definition, and you're going to show me that in a picture. That is what you're going to do. Okay? And so your homework is on Math Assistance. We'll get to this tomorrow and complete these notes. All right, it's been great teaching you. All right, I got to go. Mr. O'Neal. We out. Bye-bye.